Okay, so, I did get interrupted. That's why I paused the tape. And what I'm doing now is going back to the same old problem that we're doing. And let me just go back over that again. So I was factoring it. I factor out e to the 2x, and you get 1 minus e to the 2x. Whoops, sorry for that, but that's where I get interrupted. The next thing was plus 1 plus e to the 2x. What goes in the bottom? 1 minus e to the 2x squared. What I notice about the top, by the way, it doesn't look that bad. I mean, for example, this cancels that. Did I do a mistake over here? Yeah, no, I didn't do a mistake. It looked okay. 1 plus 1 is 2, so I'm seeing 4 e to the 2x over 1 minus e to the 2x squared. Do I see that in the key? I do. I see that's right over here. All right, so that one's done. All right, we go to the next one. The next one, again, is a derivative. It's got e to the x in it, and I'm going to write it a little differently. I'm going to write it as 20, and then I'm going to write down 1 plus 5 e to the minus 2x to the minus 1. I'm going to take its derivative. I'll call this y, by the way. So dy dx equals minus 20, 1 plus 5e to the minus 2x. That's going to be minus 2 times rid of the inside, which is minus 10 e to the minus 2x. I'm going to simplify that, and I get 200. I'm seeing that right over here. I am seeing e to the minus 2x. I did that right. And on the bottom, I'm seeing 1 plus 5 e to the minus 2x quantity squared. All right? So I'm looking at the key, and I'm looking for the answer now, and I see that in B. It's going to make sure that's true, by the way. Yep, looking good. All right, next one, logarithmic. Again, if I were taking the exam, I would not erase this. I would just go to a back of another sheet, but I am going to erase this now. And the reason for that, it's easier for me to erase than go to a back to another sheet. All right? But again, you can rip this exam apart when you're taking it. You just hand it in that answer key. All right? Let's take a look again. And, whoops, sorry about that. That eraser out, and I just got to do that again. Got the ruler out too. Let me just, for some reason, I have to do this again. Sorry about that. Okay, so I would do the log first. So I'm going to say y equals, and it's the log. It's the natural log, by the way. And there's a half power over there, so it's 1/2. And then it's going to be a quotient. I'm using what I learned from Math 119. The next thing I would do is I'd write this thing as 1/2 times the natural log of x squared minus 1 minus 1/2 the natural log of x squared plus 1. dy dx equals 1/2 times, well, that guy's derivative is this over here. It's pretty simple, by the way. And this guy's derivative is going to be, let's see, 2x x squared plus 1. All right? What I got to do, pull them together. And to do that, I notice that these 2's are canceling off, which is good news for me. So a common denominator would be x squared minus 1 times x squared plus 1. And then what do you get? You get x times x squared plus 1 minus x times x squared minus 1. I know it seems like a pain to do simplifications, but it's the whole point of it. So it's going to be x4 minus 1. On top, you can get x cubed plus x minus x cubed plus x, which gives me 2x. All right? I'm going to look for the answer. If I see it, good. If I don't see it, I'm a little concerned about it. And I think I see it. I think I see it in C. So 2x over x4 minus 1. On the next page. Next page is another quotient, and I'll write down the derivative now. And certainly, it's pretty easy to write a derivative down. Again, I'm looking for an answer. I'm not looking to impress anyone with my skills in writing things down, by the way. And this is going to be 1 plus cosine x. The derivative of sine is going to be cosine minus sine. And the derivative of the bottom is just simply, minus sine. So I'm going to say plus sine squared. What do I see over here? I see 1 plus cosine squared x plus sine squared x. And on the bottom, I get 1 plus cosine x quantity squared. Now, by the way, I do see, looking at this over here, let's see if I did this. Oh, I'm sorry, I did not 1 is cosine x. Sorry about that. I see cosine x plus 1. And I'll write this one down for you. I see cosine x plus 1. It's Pythagorean identity. Then I see 1 plus cosine x. Isn't that remarkable? Squared. It's just going to be 1 over 1 plus cosine x now. Now, granted, mistakes happen. What do? You look at the key and see if you see the answer over there. And I do. It's letter A. All right? Now, what I mean by mistakes happening, if I wrote something down that wasn't there, I say I made a mistake somewhere. All right? I wouldn't do the none of the above right away. I would do that after some considerable thought, by the way. Let me go to number 12. And number 12 is a product rule. And I'll write this down. I'm not going to say quickly, but I'm going to say 2x and then 2x cubed plus 1 to the 10th power plus x squared. And it's going to be a 10. I'm using the product rule. 2x cubed plus 1, 9th power. And the derivative of the inside is going to be 6x squared. And mistakes can happen easily. So let's take a look at this. I'm going to factor it. I'm going to factor out 2x cubed plus 1 to the 9th power. And I'm going to factor out a 2x. The question is, what are you left off with? All right, let's take a look at the first one. You left off with 2x cubed plus 1, plus. The next one, I got 30. Again, I'm looking at the number first. 10 times 6 is 60. I pulled out a 2 at 30. I pulled out the 2x cubed plus 1 to the 9th power. And I pulled out an x, so I'm left off with an x over here. All right? So what do? I'm going to look at it and see if I got something here. Oh, you know what? I forgot the x squared. It's x cubed, by the way. I forgot about that, guys. A little dot over there. So I'm looking at this over here. And I don't see the answers yet. So I'm going to say 2x and 2x cubed plus 1 to the 9th. And over here, this is 32x cubed plus 1. And do I see that? And I think I do. It's right over here. Make sure of it. Yep, I got it. All right, this one here, kind of straightforward. Probably the easiest one so far. I'm going to put this down pretty quickly. It's going to be 2, 3x plus 1, and the top's going to be 3. And I do see that like right away. I could probably do that without any work at all. Number 14 also looks like a pretty easy one. I'll write this down as 3 sine squared x times the derivative of sine, which is cosine x. Let's see, plus cosine x cubed, and the derivative of the inside of there is going to be 3x squared. All right, I'm going to look around for it, see if I see it. Oops, sorry about that. Let me take a look at that. I think it's C. Let me make sure of that. 3 sine squared. Yeah, I got cosine. 3x squared, cosine x cubed. Yep, C. All right, go to 15. 15, quotient rule. Doesn't look too bad. I got x squared plus 1 to the 4th power, x squared plus 1 squared, times 1 minus x times root of the bottom, which is 2, x squared plus 1 to the 1st power, and if the inside is going to be 2x. All right, I don't see that answer there. I'm going to factor it. The bottom is x squared plus 1 to the 4th power. On top, what do you see? I see an x squared plus 1 coming out, and we left off with x squared plus 1 minus, well, it's going to be a little tricky over here. I pulled this out, and we left over there. I got to be really careful with this. You're going to be left off with, let's see, 2, and then, oh no, 4, sorry about that. That's a 4. And then you're left off with an x squared. All right, what do you get over here? Let's see, one of the x squared plus 1's cancels out, so you get x squared plus 1 to the 3rd power, and on top you get 1 minus 3x squared. All right, now do I see that answer? I do, it's letter A. All right, I'm going to make sure of that before I go to the next page over here. Yeah, it's looking good. All right, I got a 16. 16 is, wow, looks a tough one. Let me rewrite it though. I'm going to say y equals. I'm going to say e, let's see, that's going to be x over 2 now. And this one's going to be plus e. I'm going to write this as x to the 1/2 power. Let me do its derivative, dy dx. That's going to be e to the x over 2 times a half. All right, let's do the next one. Plus e to the x to the 1/2 power. Then I got to do a derivative of the power. And that's going to be, let's see, 2 over root x. And then on top is just going to be 1. All right, so let's take a look at it. I'll rewrite it a little bit. I don't know if I need to rewrite it though. Maybe I could just look at the answer key and wouldn't it be the answer key, the A, B, C, and D, and wonder which one it is. And I'm going to say, looking at it, it looks like C right now, but I want to be careful before I say that. I am seeing this over here. I'm seeing that, e to the x, the root of it over 2, and that's e to the, yeah, that looks good. So I'm going to say C. All right, let's go to D. I'm sorry, 17, which is another derivative. And again, it's kind of tiring, but it's really kind of easy to take derivatives because they're, I'm not going to say predictable, but they're easy to write down. I mean, simplification might be tough, but that's an algebra skill. So let's say I squared the bottom, bring the bottom to the top. Oh, derivative the top. Well, that's a product rule. Let me get over there. I'm going to say e to the x plus x e to the x minus the top, which is x e to the x, times the bottom, which is e to the x. Now, certainly, I don't see that answer being listed. So then the question is, what are you going to do about it? Well, what I got to do about it, I got to expand the top. And that I say is problematic. So you get 1 plus e to the x, quantity squared. Here you get e to the x plus x e to the x. I just did the 1, by the way. That's going to be e to the 2x now. And then you're going to get, let's see, plus x e to the 2x minus x e to the 2x. Well, I see something right away. I see that this disappears. And then what do I see over here? I'm going to look at it, and I think I could probably look at the answer key now. And the way I'm going to do that is just, look at it, and it appears to be C, but I would make sure of this. I'm seeing the bottom, and let me make sure I'm seeing everything. I'm seeing e to the x, I'm seeing x e to the x, and it's good. All right, let's go to number 18. Number 18, I'm going to say product rule, and let's write it down then. It's going to be e to the 4x times minus sign x over 2 times the root of the inside, which is the half. So I'll put down 1/2. And then what do you get? Plus, well, that's going to be 4 e to the 4x times cosine x over 2. What I do now is probably look at the key and see if it's there. And I think I see it right away. I'm going to say, I think it's A, but let me make sure of that. I do see that. And am I seeing that in A? I certainly am. So it's letter A. All right, that's 18. Let me go to 19. Now, if you can't remember 19, that's fine, by the way. But I would move to a different problem. But the arctangent derivative, that's not so bad. That's going to be 1. And it's going to be 1 plus the argument squared. Well, the argument is, that root problem, so it's just going to be x squared minus 1. Well, that seems to be pretty inconvenient. Pretty convenient. What do you do now? The derivative of the inside, which is going to be 1 over 2 root x squared minus 1, and top which is 2x. All right, let's simplify. And I notice here that this thing over here is just x squared. So I'm looking at this, I'm going to see a 2. Oh, no, the 2's cancel too. So I see a 1, and I see an x canceling, and then I get this over here. All right, let me see if I see that in a K. And I do, and that's letter C. Okay, let me go to 20. And 20 is another derivative. They're all derivatives, by the way. Let's write this down. x6, x cubed, derivative of the natural log is 1 over x, minus the natural log, times the derivative of the bottom, which is 3x squared. All right, let's simplify. You get x squared minus 3x squared ln x over x6. I'm going to divide through by x squared, by the way. And what do you get? 1 minus the natural log, 3 natural log of x. And on the bottom, I divide by x squared, right? So x4. Now, Greta, if I don't see that answer, you're a little concerned that I made a mistake somewhere. But I see the answer. I think I see it in B, but I want to make sure of that. 1 minus, yeah, looks good. Let's go to 21. And 21 is a derivative problem. And I'm going to write it down. It's an implicit differentiation. So the first thing is that the derivative of natural log is 1 over that argument, which is going to be y over x. It's a reciprocal of that. Times the derivative of the inside, which is going to be y squared. I bring y, derivative of x is 1, minus the top, which is x, times the derivative of y, which I'm going to put down y prime. So the left-hand side is done. Let's do the right-hand side. Oh, by the way, this simplifies. We'll do that later, by the way. This is going to be e to the x y cubed times the derivative of x y cubed. Well, I'm going to say it's y cubed plus 3x y squared y prime. Again, if you think this is overwhelming to get y prime, I would avoid the problem and just go to a different one at this point, saying it's so much work, I don't know if I want to do it. But I want to go through it with you. So the y's cancel off, and I'm left off with a y over here. All right, so what do I get? I get y minus x y prime. That's what I get in top, by the way. And at bottom, I just get yx. All right, let me put this one down for you. This is going to be e x y cubed times y cubed plus, 3x y squared e x y cubed y prime. All right? So what I'm going to do now is clear the fraction. I get y minus x y prime. What are you going to get there? You can get y4, x, I'm multiplying both sides by yx, by the way. And then you get e x y cubed plus 3, that's going to be x squared now, and then a y cubed. E x y cubed y prime. I'm going to put the y primes on one side and the other things on the other side. So I'm taking these two things over here, and I'm going to factor as I do that. So it's going to be x plus 3x squared y cubed e x y cubed y prime. All right, let's see if I did that right. I got this, I got that. I think I copied okay. Next thing up, but the other side, it's going to be y minus y4 x e x y cubed. All right. Right now, I don't know if I want to rewrite. I want to look at the question and see if the answer is remotely close to what I'm thinking it's going to be at this point. And I'm looking at B as being a very favorable candidate. But I want to make sure that's true, by the way. I'm seeing the y, I'm seeing the x, y4. I do see that. I see this, I see this, I see this, I see this, I see that. I didn't bother writing it down, by the way. And what do you mean by that dividing both sides? I see that now. All right, I'm going to get my eraser out and erase this business over here. Again, on the exam, you can just rip your pages apart and, back on another sheet, so to speak. So I'm going to put number 22 down. It's another implicit differentiation problem. And I'm looking at it. I'm going to say maybe I should just rewrite it. Maybe I should write it as, let's see, secant of y. Let's write this over here. X equals secant of y. And then what I'm going to do is I'm going to write this as, let's see, let's put this down now. It's going to be, that's an implicit different, 1 equals, let's think about this. The derivative of secant is going to be secant y tan of y. And then the derivative of the inside is going to be y prime. All right. So as soon as you get a problem now, I don't see the answer being listed over there. So what I want to do is just talk about, the triangle, what it looks like. It's a right triangle. And the angle's y, and the secant of y means the cosine of y is just going to be 1 over x. That means this is 1, this is x. What's this over here? It's a root problem. What's the root going to be? Let's see, x squared minus 1. So this is going to be 1. What's the secant going to be? Well, the secant just x. That was not a problem. But what's the tangent going to be? And it's tangent of y. It's going to be this. And then y prime. This cancels. You get 1 over the root of x squared minus 1 equals y prime. Is that answer being listed? That answer is being listed. Make sure I didn't make a mistake over here. Let me see if I made a mistake here. Let's see, secant x, I did that 1, secant y tan y, y prime. I think I did okay there. The tangent, oh, you know what, I made a mistake. I just see it right now. I'll erase this now. So let's write this down. 1, secant of y is x, that's a given. The tangent of y, that's where I made my mistake, is x squared minus 1 y prime. Do I see that answer being listed? Let me be careful again. Yes, it's letter B. All right, let's go to 23. 23 is the arctan function. All right, again, if you can't remember the derivative of arctangent, a little reason for concern, but it's really not that bad. I'll put this one over here. It's 1 over 1 plus the argument squared, which is 2x plus 3 squared, times the derivative of the inside, which is 2. Doesn't look that bad. I'll write this down. I don't see that answer, by the way. 2. This is 1 plus 4x squared plus 12x plus 9. And it's going to be 2, 4x squared plus 12x plus 10. I still don't see the answer. Divide by 2, 1, 2x squared plus 6x plus 5. Again, I'm hoping to see the answer, and I think I see it. It's letter C. Let me just make sure of that. Yeah, it looks pretty good. All right, this one over here, again, it's implicit differentiation. If you have a tough time with that, I would say, move on to a different question. I'm going to get my eraser out again, this business over here. Again, we're only looking at your answers, not your work. So this one over here, let's take a look at it. The arctangent, wow, that keeps popping up, doesn't it? So it's going to be 1 over 1 plus x4 y squared times the derivative of the inside. And the derivative of the inside is going to be 2x y plus x squared y prime. All right, let's go to the other side. It's not that bad. It's going to be 1 plus 3y squared y prime. Let's make sure I did that right. And I'm looking at it. Yeah, it looks pretty good. I don't see the answer there. So I'm going to write it down a little differently. 2xy plus x squared y prime. I can multiply both sides by the LCD, and that's this thing times those two terms. Well, it looks pretty easy to do. It's going to be 1 plus x4 y squared plus, well, let's take a look at this one. It's going to be 3y squared y prime plus, a little more complicated, it's going to be 3y squared, y4, and then x4 y prime. All right, you're going to get the y primes on one side, everything else on the other side, and that's going to be 2xy, let's see, minus 1 minus x4 y squared, and I'll get the y primes on the other side. And that's going to be, I took care of a lot of things at this point, but let's write this down. I would see 3y squared plus 3y4 x4, and then minus x squared y prime. And this is where I'd kind of like look at the problem and see if I see it. And I got to be careful now, see if I'm seeing it. And I think I see this. I'm going to make sure of it. I see that, I see that, I see that. Am I seeing this thing on the bottom now? 3y squared, 3x4y4. Yep, it's letter A. All right, let me go to 25. 25's product rule. What do you get over there? x4 times the derivative of natural log, which is 1 over x. Boy, it's like deja vu. Plus, let's see, 4x cubed times the natural log of x. That's our first derivative, by the way. I'm going to simplify it. It's going to be x cubed plus 4x cubed ln x equals y prime. I'm going to factor out an x cubed, by the way, because it might make it easier for me to take the derivative. It's going to be 1 plus 4 natural log of x equals y prime. What's y double prime going to be? Well, let's see. I'm going to say 3x squared, 1 plus 4 natural log of x. Let's see, plus x cubed times with the inside, which is going to be 4 over x. Let's write this down because I don't see the answer. This is going to be 3x squared plus 12x squared ln x minus 4x squared. I'm sorry, plus 4x squared. Okay, I'm going to look at the key now and see if I see it. And I'm seeing 7x squared. It's either A or B at this point. I'm seeing that. And then I'm seeing 12 ln x squared. Yep, it's letter B. That's done. All right. Let's do the next one. This is going to be 26 now. And 26 is another derivative problem. And to go through that derivative, let's take a look. Really not that bad. 1 over 2, the root 1 minus x squared. The top would be minus 2x. All right, let's do the next one. Ooh, arc sine. Got to remember that now, right? So, wow, let's take a look at that one over there. So it's going to be x times root of the arc sine. That's going to be 1 over the root of 1 minus x squared. Well, I'm going to keep going, don't I? Plus arc sine. Well, what I notice about these guys over here, if I cancel this over here, these would be direct opposites of one another. So I'm going to say arc sine of x. All right, that's letter A. Let's go to 27. That's an arctangent problem. And let's write this down. I got a square on it. So I guess I got to do this. 2 arctan of 4x. Whoa, I got to go to the inside now. And what do I get over there? I'm going to get 1 over 1 plus, that's going to be, let's see if I'm doing that right, 2. That's 2 times that. I got to be careful now. I got to maybe get tired of the exam here. 2, I did that, I got the 1, I got that. The derivative of arctangent is 1 over, let's see, 4x squared. Get that okay over there. And then what do you get? The derivative of the inside is going to be 4. Wow, that was a tough one, wasn't it? So what do I see? I'm looking at my answer key now. I'm looking for 8 arctan 4x, and I do see that here. And I want to make sure I'm getting the same bottom. And I am. I'm getting 1 plus 16x squared. So letter C. All right. This one, another derivative. Let's write it down for you. It's a natural log. That's going to be squared. Bring it to the top. Derivative of the top is going to be 2x minus the top times the derivative of the bottom, which is 1 over x. All right? Looking at it, I'm going to multiply top and bottom by x. All right, I'll write that down for you. You're going to get 2x squared, natural log of x, minus x squared plus 1 over x ln x squared. All right, you look at the k, and this is problem number 28. I'm seeing, it looks like it's B at this point. I want to make sure. 2x squared ln x minus x squared plus 1. Yeah, I got that one. All right, this one over here, log base 2. And someone says, I don't remember log base 2 problems. And that's a problem. Let me go derive it for you, though. If you have log base 2 of a number, let's just call it x, it's the same thing as saying the natural log of x over the natural log of 2. All right? So log base 2 of this thing over here, it would look kind of crazy. Well, I'm going to use rules of logs first of all. So it's going to be log 2x plus 1/2 log 2, 1 plus x squared. All right, I'm going to take its derivative now. And the way I'm doing that, really I'm taking a derivative of natural log. So it's going to be 1 over, the derivative of natural log is going to be 1 over x, but I'm going to put an ln 2 over here. Plus 1/2. Derivative of natural log is 1 over x squared, right? But I still got to put an ln 2 over here. And chain rule, I got to put 2x over here. So what do you get over here? Let's see. You can get 1 over the natural log of 2x plus x. The 2 cancels, by the way. 1 plus x squared, ln 2. I'm not seeing the answer, by the way. So what do you do? I'm going to factor the ln2 out. And what do you get there? You get 1 over x plus x over 1 plus x squared. Whoa, I got to do more. 1 over ln2. Common denominator x, 1 plus x squared. And this is going to be 1 plus x squared plus x squared. I'm ready to look at my key. What am I looking for? I'm certainly looking for ln2 on the bottom, and I'm looking for x, 1 plus x squared. And I see it. I see it in more than one spot, by the way. But I'm looking for the numerator, and the numerator I'm looking for is 1 plus 2x squared. And do I see that? I think so. I think I can see it right over here. I just want to make sure I'm seeing that before I say it's that. I do see the ln2, see the x, 1 plus x squared. I do see that, and I see 1 plus 2x squared on top. Looks great. Can I get my eraser red again? The last question. I know this is very tedious. A lot of people get annoyed by the tedium of taking derivatives, but it's something you want to practice. And it's going to be another derivative. They're all derivatives, and I'll write it down for you. So it's going to be x squared minus x plus 1. Bring it to the top. To the top for the easy, just 1 minus the top times derivative of the bottom, which is 2x minus 1. And I'm not seeing that answer. So I'm going to expand it. Oops, the bottom is squared. Sorry about that. And if you did the top, you get x squared minus x plus 1. A little more tedious over here. I got to do this over here. So minus x, that's going to be minus 2x squared plus x. And this is going to be plus 1, so it's 2x minus 1. Let's see what I get there. I get minus x squared. Let me see if I did that right. X squared minus x. Oh, I'm sorry, I'm looking at 29. I'm looking for the answer there. I don't see those answers there. So I'm seeing minus x squared. I do see that here. I just want to make sure I'm seeing everything. So x squared minus x plus 1, I do see that. I see the minus x squared. Let's see, I see the 2x, and the 1's disappear. So that looks good, letter B. And we're done. I know it's a long test. The thing about this one over here is that you're expected to do 25. This is your answer page over here, and the answer page should be filled out. Thank you.